All right, so today we're going to talk about a different type of logarithm, which comes from a different type of exponential base. The good news is the bases, the exponent base and the logarithms are all going to follow the same rules that we had for all of our other logarithmic work. So it should be pretty straightforward, should be pretty easy. We should be able to handle it pretty well. So they're called the natural logs. We need to be able to evaluate and simplify natural logarithms and then solve equations. We'll get to all of that, right? So, like I said, it's a different type of exponent base, which comes from a different type of number. And there are different famous numbers. The counting numbers is what we started counting everything with, 1, 2, 3, 4, 5, 6, 7. Negative numbers we introduced because we wanted to be able to subtract things, right? 0 is a very powerful number. We've talked about that. Civilizations, it took a while for them to actually accept the idea of 0, just because of its powerful nature. Pi came about from trying to estimate the area of a circle. It eventually became defined as the circumference of a circle divided by the diameter. We know about pi. We've used pi before. It's an irrational number that the decimal does not end, does not repeat. Imaginary numbers we know all about now because we got negatives inside of radicals, and that was all kind of weird, and so we had to deal with that as well. Now we've got the next famous number, and there are all kinds of these constants throughout mathematics, but the one for us today is what's called E. E comes about from when a couple of mathematicians, Leonhard Euler and Bernoulli, studied compound interest. And when they studied compound interest, they discovered that this constant, this 2.718281828459, kept coming up. And so it was a value that they wanted to give. It was a consistent number that kept coming up, and they wanted to give it a name. So Leonhard Euler named it E, whether it was after his name or because of its exponential nature, I'm not really sure. But E is called the natural base. That decimal, which does not end, does not repeat, is an irrational number. Occurs in nature quite a bit too. Feel free to Google it, and you'll see what I'm talking about. Also called the Euler's number because, again, it was discovered or at least named by Leonhard Euler in 1736. Quick history lesson on Euler. He was a famous mathematician who's actually lent his name to several other things in mathematics. He's published several books and papers, and interestingly enough was blind when most of those books came out. There he is. He studied in Switzerland, Germany, Russia. He had 13 kids, just a small army. Had an amazing memory and was known as a computational genius, kind of a savant. Right? All right, evaluate expressions. If we wanted to evaluate these guys, e to the third, e to the 0.7, and negative 1.2 times e to the fifth, right, you would need to grab a calculator because there's no way we're going to be able to do this by hand. So bear with me for a second while I bring up my calculator, and I'll show you where to find it. Okay, so here it is. E. You'll find E right above the LN button, right on your calculator, graphing calculator, or even on a scientific calculator. It's usually right above the LN button. You have to use your second or shift button to get to it. And it would look like this, or it might look like, let me change my mode here to show you what it might look like in a different type of calculator. So if I hit that again, it might give you this caret with parentheses, and then you just type in whatever it is that you want to raise the e to the power of. So e to the third power, close that parentheses and hit enter, and so you should get 20.09, right? So e to the third is 20.09. So we go in here and make this 20.09 to the nearest hundredth, right? E to the 0.75, negative 1.2 times e to the fifth. You can try and type those in. I'll give you a second. and then show you how to type those in and make sure you're doing it correctly. Okay, so e to the, I've already forgotten, 0.75. So we want to go shift e to the 0.75, close those parentheses, and hit enter, and you get 2.12. Okay, and the last one, negative 1.2 times, pretty straightforward. Just make sure that you're hitting negative 1.2 times. Then your shift E to the fifth power, sorry. Close your parentheses, hit enter, and you get negative 178.09. If you're not getting, sorry, actually should be 0.10. If you're not getting that, make sure you come and see me, and we'll sit down and go through your calculator functions, right? Now, because e can be the base of an exponent, we can also rewrite that as a logarithm. Those guys come together. When you do base stays base, we write log base e of x, it actually is considered, it's called the natural log, the natural logarithm, and instead of writing it like this, we write it as this, ln of x. Anytime you see an ln, that means that the base of the logarithm is e. Anytime you want the base of logarithm to be e, you want to write that as ln. All right? So to evaluate it, again, you've already found the ln button. We can just use it now. So natural log of 0.1, we just go to, instead of hitting the second button, just go to your ln button and go 0.1 and close your parentheses. And hit enter, you get negative 2.30. Pretty straightforward. Go ahead and type in the next two. Make sure that you can get the values that I'm getting ready to give you. I'll give you a second. Okay. So natural log of 200, you just type in natural log of 200. Hit enter. Well, close your parentheses, then hit enter. And you get 5.30. And the natural log of 0.25. Close your parentheses, hit enter. Negative 1.39. Okay? Hopefully that's pretty straightforward. Again, if you're having problems with your calculator, just make sure you come see me and we'll figure it out. Right, now, we need to be able to shift back and forth between logarithmic and exponential forms. And it works just like it did for all of our other logarithms, right? So here, if I want to rewrite the natural log of 125 equals x into exponential form, remember base stays base. The base of the natural log is e, so my exponent base is going to be e. And the other two place switcheroo. So e to the x is equal to 125. That's like an L, but it should be an E. The second one, again, E, and then switch the other two guys to the 4.82 equals X. All right? Try the third one. Stop the video for a second. Write it if you need to, or maybe you've already written it by the time I've done talking, saying all this. But anyway, if you rewrite it, it should look like E to the X equals 52. Okay? And same thing going the other way. From exponential form to logarithmic form, base stays base, the other two place switcheroo. Just like I said, make sure that you don't get caught in writing log base e, right? No one does that. So if the logarithm base is e, we're going to write this natural log, and then we're going to rewrite these two as natural log of x equals 2. The second one, the base of the logarithm is e, so we'll make this natural log, and then switch the other two guys of 1.44 equals x. All right, try the third one. Stop the video, start it back up, make sure you got it right. So you should have gotten natural log of 3.83 equals x. Okay? If any of those are confusing, again, make sure you come in and get some help. All right. Now, if we want to start solving equations, the process is exactly the same as it was for other logarithmic equations and other exponential equations. Here, we need to get the natural log all by itself. So this block right here we need to get it all by itself. Solve for it, right? Which means first thing you want to do is subtract 3 from both sides. Bring down that minus sign as a negative for the 4. And then divide both sides by negative 4. Now, you do not have a logarithm on both sides in which to drop. And you cannot evaluate the natural log of 8x plus 1, so we need to write this in exponential form. Base stays base, so e to the negative 9/4 equals 8x plus 1. So you've got to be careful when you type in e to the negative 9/4. But we want to type that into our calculator, get that value, and then we're going to subtract 1 from it, and then divide by 8, right? We're just going to mentally solve for x here. So, let me show you what that would look like. Right? So we want to go, sorry, is it natural log? No, e. So we want to go second e. Now, see how I open up the parentheses? You want to type in negative 9 divided by, use the divided by button, 4, close those parentheses. Very important to close those parentheses. And then hit enter. And then do some mental math. If it's equal to 8x plus 1, that means we got to subtract 1, then divide by 8. So just hit minus 1. And then divide by 8. And there you get a nice unrounded decimal as your answer, which we will now round to the nearest hundredth. And again, x is equal to negative 0.11. Or whatever steps it takes to get to negative 0.11. Okay? All right. Same thing with 14, right? We want to get the natural log by itself. So add 7. And so we get a natural log of 2x equals 11. Again, we do not have natural logs on both sides with which to drop. And we cannot evaluate the natural log of 2x. So I'm going to rewrite this as e to the 11th equals 2x. Now we've got to find out what e to the 11th is, and then divide that by 2. So we go back out to our calculator. Second, e to the 11th, close those parentheses, hit enter, and then divide by 2. Which gives us a huge number, 29,937.07. Right? 29,937.07, if I remember right. We'll check it just to make sure. Yep. Which makes sense. Remember that e is 2.7 basically, right? If you raise that to the 11th power, it's going to get you a pretty big number. Okay? All right. Try 15. Stop the video, start it back up, and make sure that you get to the right answer. And this is what it should look like. Divide both sides by 5, rewrite in exponential form, and then continue to solve. You should get 7.36. If you did not, come in and see me. We'll figure out why not. Okay? 16. Now, 16 has 2 natural logarithms on one side of the equation. That's 1 too many. So we need to condense this down. And it works just like it did for the other logarithms. Addition condenses down into 1 logarithm, and we have to use multiplication, 2x times 3. Okay? Remember that 2 logarithms condense down to 1 logarithm, not 2 logarithms condensing down to 0 logarithms. In other words, don't drop the ln. Keep it there. Now, 2x times 3 is 6x. And then, again, there's not a logarithm on both sides to drop, and we can't evaluate the natural log of 6x. So we want to rewrite this as e squared equals 6x. So we're going to type that in and then divide by 6. So e squared and then as long as you're closing your parentheses, you can always just type in divide by 6. and you get 1.23. So x is 1.23. Okay? Um, 17, again, two logarithms we need to condense down to one. But this time subtraction condenses down into division. Again, make sure that you bring down your ln. We do not have a logarithm on both sides of the equation with which to just drop, and we can't evaluate the ln of x over 5. So we need to rewrite this and change the forms. So we go e to the negative 1 equals x over 5. And then we know that we're going to multiply both sides by 5. So type in e to the negative first and then multiply by 5. And when we do that, we go shift e to the negative first. Close that parentheses. Check one more time. Yes, we're multiplying by 5. So I can go ahead and hit times 5 now. Hit enter and get 1.84. Okay. All right. Here's 18. Give it a shot. Stop the video. Start it back up. Make sure that you've done it correctly. If you haven't, and you can't see why not, again, make sure you come in and see me. Did you get 5.02? I hope you did. Okay. There's the work. If you didn't get that, you don't understand why, come in and see me. Right? Now let's get to some exponential equations, and the same thing happens here that happened before. We've got to get the exponents by themselves. So on 17 here, we've got to make sure we divide both sides by 7. We go e to the 5x plus 8. And I'm not going to divide this out. I'm going to go ahead and leave it as a fraction. Right? You might want to also. It's just easier. And then we don't have an e on both sides, an exponent base on both sides to just drop. So, and we can't evaluate e to the 5x plus 8. So that means we have to rewrite this in logarithmic form, right? So base e for a logarithm means we're going to do ln, and then we're going to switch. 0.23 goes over here, divided by 7 goes over here. The 5x plus 8 goes over here. So this means that when we get our value of natural log of 0.23 divided by 7, we want to subtract 8 and divide by 5 to get x. Again, we're going to skip a couple of steps here. But I'll show you what it looks like. Right? 0.23 divided by 7. So we go natural log of 0.23 divided by, oh, too many decimals there. Let's delete one of them. Divided by 7. Make sure you close your parentheses and hit enter. Another quick check. Yes, we got to subtract 8, divide 5. Now we're going to subtract by 8, divide by 5, and we get negative 2.28. Okay. Number 20. A lot of the same, right? So we're going to subtract 6 here. Make sure to bring this minus sign down as a negative on the e. You've got to, because this is going to give you negative 0.8. Now we've got to divide both sides by negative 1. Otherwise, when we rewrite this in logarithmic form, we're going to end up with a negative inside of a logarithm, and we can't do that. Okay? Again, we cannot evaluate e to the 12x. We do not have an e on both sides with which just to drop. So we're going to rewrite this as natural log of 0.8 equals 12x. That means evaluate natural log of 0.8 and divide that by 12 to get your value of x. Oop, I did not close my parentheses. Now divide by 12. And you get negative 0.02. Okay? All right, hopefully that's enough. Try this one. Stop the video. Start it back up. Make sure you got it right. And if you're good to go, then you can get to your homework. All right, so there you go. That's what I was just talking about. We end up getting a negative inside the natural log. You still cannot take the natural log of a negative number either. That means we cannot finish solving this guy, so it's no solution. Okay? Make sure that none of your solutions are giving you a negative inside of your natural logs. We need to check back in our previous problems. No negative there, so we're okay. No negative there, so we're okay. Looking for a negative solution. And it didn't look like, well, we had one here, but if you plug the negative 0.11 in for x, you're going to get negative 0.88, and when you add 1 to it, it turns back to a positive, so no extraneous solution there. So we're okay. All right? Homework's out on campus. Make sure you have it done by next time.